We've used disk diffusion susceptibility methods before, but let's look a little more closely at some of the principles behind this test. Many chemicals can be tested using disk diffusion. You simply impregnate a piece of filter paper with the chemical you wish to test, and when you put it on agar, the chemical will diffuse into the agar. Organisms will either grow or not grow in the presence of the chemical. We can test antiseptics, disinfectants, and antibiotics using this technique. Antiseptics, you'll remember, are chemicals that can be used on skin. Disinfectants are used on inanimate objects, and antibiotics are taken internally. When we're testing, there are certain factors that will affect the disk diffusion technique. One is the agar used. Different agars will give you different results. You also need to make sure that the agar depth is consistent from test to test. When those chemicals diffuse, they not only diffuse away from the disc, but they also diffuse into the agar. If the agar is too deep or too shallow, it will affect how far the chemical diffuses from the disc. You must meet the appropriate incubation conditions for the organism you're testing, and you need to use a consistent amount of organism every time you do the test. All of these conditions must be constant from test to test. Antibiotic susceptibility testing using the disk diffusion technique is the Kirby-Bauer method. The media they use is Mueller-Hinton media, and there is always a standard depth to the media. Broth cultures of the test organisms are always standardized to a turbidity that's equivalent to a McFarland 0.5 turbidity. This is a particular turbidity standard that's used when you're making up these dilutions. The zone diameters have been standardized so that we know that the organism is either susceptible or resistant to the drug being tested. When we're testing disinfectants and antiseptics, the standard tests are the phenol coefficient, which is the old standard. The newer standard is the use dilution test. We're going to sort of use a disk diffusion method that's a crude approximation of the use dilution test. We're going to soak filter paper discs in various chemicals that we're going to test. We'll make a light suspension of each organism we use. We will make the suspension the same turbidity for every organism. This should mean that we're testing approximately the same number of cells. Because these zones of inhibition will not be standardized, we'll only be able to compare zone sizes from chemical to chemical with the same organism. To do the test, we will insert a sterile swab in a broth culture of the test organism. You sort of wring the swab out on the sides of the tube so it's not real soppy. Then you streak the plate in 3 directions. You streak one way, then you streak at right angles to the first, and then diagonally. This should give you a uniform lawn of organism on your plate. Place the filter paper in the center of the plate. We'll incubate at 37 degrees centigrade for 18 to 24 hours. Then you'll measure and compare your zone sizes of chemicals. Remember, this is not standardized, so you'll simply say things like, well, the zone around this chemical is much larger than the zone around this chemical for the same organism. It's more of a comparison than actually a true test.